In this video, I want to discuss price elasticity from the perspective of a product or brand manager. Price elasticity helps you think about how sensitive demand is to changes in price. Fundamental questions. Number 1. If you increase price, will the increased revenue from the price increase more than compensate for the lower sales volume? Number 2. If you decrease price, will the increased revenue from higher sales volume more than compensate for the lower revenue due to the price decline? Your price decreases. What happens to your total revenue? Does it increase or decrease? The answer is, it depends. Here is a stylized graph relating price to quantity demanded. This is a demand curve. Except for very rare instances that we will leave aside, demand curves are always downward sloping as demand drops when prices increase. Total revenue is price times quantity. This is the area of the rectangle shown here. Now let's introduce a drop in price from P1 to P2. The price change is associated with a large change in demand from Q1 to Q2. When small changes in price are associated with large changes in demand, we call this elastic demand. It is typical of non-essential product categories, such as dining out at a restaurant. What happens to total revenue? The panel on the right shows that total revenue increased. The rectangle representing the new total revenue is much larger than the one on the panel on the left. The loss in revenue due to the price drop is more than offset by the increase in revenue from higher sales volume. Now let us consider the situation where price does not have a big effect on quantity demanded. We call this inelastic demand. Inelastic demand is typical of essential goods categories. If the price of gasoline declines, you might drive a little bit more, but you are not going to, say, purposely drive a longer route to get to work because gas prices are cheaper. What happens to total revenue in an inelastic market when price decreases? The panel in the lower right shows that total revenue decreased. The rectangle representing the new total revenue is smaller than the one in the panel on the lower left. The loss in revenue due to the price drop was not offset by the increase in revenue from the higher sales volume. To summarize, when demand changes very little with changes in price, i.e. demand is inelastic, total revenue changes in the same direction as the price change. Examples include essentials such as gasoline or salt, and tickets to a popular concert. When demand changes a lot with changes in price, i.e. demand is elastic, total revenue changes in the opposite direction of the price change. Examples include non-essentials such as dining out. What factors contribute to how sensitive demand is to changes in price? Number 1, product choices. Consider toothpaste. A typical drugstore offers many product choices differing by pack size, package shape, paste or gel, flavor, etc., allowing consumers to compare prices across the different choices. Contrast that with a small convenience store that may only have 1 or 2 product choices in a product category. Number 2, substitutes. Consider apples. If I'm buying some McIntosh apples, the supermarket has many other types of apples, Fuji, Gala, Red Delicious to name a few, that I may view as close enough substitutes so that the price of McIntosh apples may cause me to buy another variety in a given week. Also, a market that is narrowly defined will have fewer substitutes. Think of, say, apples for which other fruit may substitute versus, say, food in general. Number 3, brand loyalty. A focal objective of marketing is to build brand loyalty with an eye towards attenuating the effect of price on demand. Loyalty to, say, the Colgate brand of toothpaste may mean I really do not view other brands such as Crest as close enough substitutes. Number 4, consumption behavior. A less flexible time frame is associated with demand being less sensitive to price changes. Think of a cold when I am sick, or an umbrella when it is raining. The demand for products viewed as necessities are less sensitive to changes in the price than those viewed as non-necessities or more discretionary. Also, some products like, say, chewing gum are a very small percentage of my income, so I'm less price sensitive to changes in price. Number 5, commoditization. The more a product is viewed as interchangeable with other products of the same type, the more price sensitive buyers will be. And again, when demand changes little with changes in price, any change in total revenue is in the same direction as the price change. That is, if prices increase, total revenue increases. Conversely, when demand changes a lot with a change in revenue, total revenue changes in the opposite direction of the price change. If price increases, total revenue decreases. A fundamental equation. To quantify how sensitive demand is to changes in price, we focus on percentage changes. Percentage changes are unitless, which is helpful as then we are indifferent as to whether demand is measured in dollars, units, weight, etc. Percentage change in demand equals a scaling constant called elasticity times the percentage change in price. Price elasticity is always negative since higher prices are associated with lower demand. When elasticity is between 0 and -1, we call it inelastic since a given percentage change in price is associated with a small percent change in demand. When elasticity is greater than -1 or more negative, we call it elastic since a given percent change in price is associated with a larger percent change in demand. In general, we are interested in how sensitive demand is to changes in things besides just our price. These include a competitor's price, i.e. the price of a substitute. For example, how sensitive is the demand for Crest toothpaste to changes in the price of Colgate toothpaste? Here elasticity is a positive number. The price of a complementary good. For example, how sensitive is the demand for hot dog buns to the price of hot dogs? And buyer's income. This is a little complex, so we will look at it in the next slide. Sensitivity of demand to changes in a buyer's income can be positive or negative depending upon the type of expenditure. Discretionary expenditures like dining out tend to be very sensitive to changes in income. In the US, under a strong economy, on average about 50% of a household's expenditures on food goes to restaurants, but it is considerably less in tough economic times. Necessities like the speed of your home internet connection also tends to be positively associated with changes in a buyer's income. Necessary medicines to treat chronic ailments should not be affected by changes in a buyer's income, assuming they can afford it. And finally, there are some categories where demand has an inverse relationship to a buyer's income, ramen noodles being the quintessential example. Back to price elasticity of demand. Consider two prices and the corresponding quantity demanded at each price. What is the price elasticity? Recall that elasticity is the percent change in quantity demanded over the percent change in price. Percent change in quantity demanded is the change in quantity over the quantity. For the denominator, we use the average or midpoint. In this example, the change in quantity of -5 over the midpoint 27.5 is -18%. Similarly, the change in price of $1 over the midpoint $1.50 is 67%. So the price elasticity is the negative 18% over 67% or -0.27. Calculating the elasticity using two data points is called the arc elasticity. It is easy to compute. It does not make any assumptions about the relationship between price and demand, and it does not control for the effects of other variables. Here is the quantity demanded at 3 additional prices and all 4 arc price elasticities. Notice that as prices get higher, demand becomes more elastic. In this example, at higher prices, demand is more sensitive to price. This slide plots the demand curve, which is a plot of quantity demanded versus price. Demand curves are always, at least for the examples we will consider, downward sloping. As price increases, the quantity demanded declines. The relationship in this example is linear. The slope is a constant -5 units of demand for each dollar increase in price. The price elasticity does not have a linear relationship with price. The marginal increase in price elasticity increases with increasing price. This is graphed in the bottom panel. This panel to the right is a demand curve that is much more sensitive to changes in price. There are now larger changes in quantity for the same change in price. Notice that the price elasticities are now larger, more negative, in the bottom panel, and the marginal increase in price elasticity is even larger with increasing price. Until now, we have considered only demand curves that are linear. The rightmost panel is a demand curve that is nonlinear. The marginal drop in demand as price increases declines with price. The flattening out in demand from $4 to $5 has intuitive appeal as it suggests a segment of loyal buyers who continue to buy at high prices. Notice in the bottom right panel that the price elasticity flattens out with flattening of the marginal change in demand. With multiple data points, you can create a model that describes quantity as a function of price and possibly other variables such as advertising effort. We can write a quantity demanded as a mathematical equation. Here the model is quantity equals 35 minus 5 times price, which is written below the graph. The slope of the line relating price and quantity declines at a rate of 5 units of quantity for every dollar increase in price. This is a linear functional form. The continuous function analog of a change is differentiation from calculus. Working through the math, the equation becomes diquantity by diprice times price over quantity. For a simple linear function like we have here, diquantity by diprice is just the slope, minus 5 in this example. The price elasticity is then minus 5 times price over quantity. Finally, quantity equals 35 minus 5 times price, so we substitute that into the denominator. There are other functional forms besides linear that are more commonly used in practice. While a linear functional form is simple to explain, its elasticity formula is very complex. Price elasticity is a function not just of price, but also every other variable that affects sales. In practice, a nonlinear functional form, exponential or multiplicative, is used for reasons that include a simpler formula for elasticity. It ensures predicted quantity is non-negative, and it implicitly accommodates interactions amongst the variables in the model. These are presented here, but we will not go into details at this time. Having an estimate of the price elasticity for your product category can be a useful way to begin thinking about how prices affect sales volume. Where can you find such an estimate? A Google search may lead you to a study someone has done that reports a price elasticity for your category. It may be from a different time or geography, but it is a starting point for you to then adjust using managerial judgment. A second source for an estimated price elasticity is a meta-analysis. A meta-analysis summarizes past studies into the median elasticity across all those studies and provides adjustments from that median based upon the context. Context can be, say, US versus Europe, or frequently purchased products versus durables. About every 10 years or so, someone publishes an update that considers studies published since the last meta-analysis. A published meta-analysis reported a median elasticity of minus 2.2. So to account for publication bias, a good starting point is a slightly lower value, say minus 1.5, as your price elasticity absent any other information. This slide depicts two product categories. Those in blue are price elastic, those in red are price inelastic. This stylized graph shows a typical frequency distribution of price elasticities considering many products and product categories. The horizontal axis is the absolute value of price elasticity. The vertical axis is the number of products having a given price elasticity. How does someone like a retailer who has a portfolio of products for sale think about optimizing prices? The retailer is making trade-offs between products that contribute to top-line revenue, i.e. price times volume, and those that emphasize bottom-line profit, i.e. contribution margin times sales volume less fixed costs. If, say, price increases, then revenue also increases if it is an inelastic good, or revenue decreases if it is an elastic good, and vice versa for a price decrease. This graph is a stylized example of how to think about what we will call the frontier. For a product's given contribution to revenue, are we also maximizing its contribution to price? Should we view the product as one that will drive margin, drive traffic to the store, or some combination of the two? This topology categorizes a retailer's profits into 5 groups. We call revenue as price times quantity. At one extreme is a margin-enhancing product, one where, say, a price cut drops revenue a bit, but profit increases significantly. You drive profit without sacrificing dollars. At the other extreme is a traffic product. Profit changes little with changes in total revenue. These are products that affect your overall price image and help to drive store traffic. These are your KVCs, key value categories, or KVIs, key value items. In practice, how do you assess the price elasticity and related profit versus revenue contribution for every item in a retailer's store? The volume of data is huge, so it is going to require a combination of reliance on historical transaction data and using your own intuition. In summary, price elasticity of demand helps you to think about how sensitive demand is to changes in price. When demand is relatively insensitive, revenue changes in the same direction as a price change. When demand is sensitive to changes in price, revenue changes in the opposite direction to a change in price. Finally, remember that elasticity is not the slope of the demand curve. It is the ratio of percent change in demand for every percent change in price. It is unitless. Further reading. This concludes this video.